In this example, we're just going to do away with an exact function so that we can kind of boil things down to just the key ideas here. So we've collected some facts about some function. So we shouldn't be getting distracted about how to compute derivatives, how to compute limits, all that. Let's say it's already given to us. We've already done the work. And so here's the key information we've gathered. We know that at 0, the output is 3, and at 2, the function is 1. So this gives us some anchors, some places to kind of nail down the graph. We know it has to pass through these 2 points. Then we find out that the derivative is 0 at 2. So here's a critical value, right? So some critical value. We know that the derivative is negative whenever x is less than -1, or whenever x is between -1 and 2. It didn't say anything about the derivative at -1, so that gives me, that means something's interesting probably happening there. And then the derivative, is positive whenever x is greater than 2. So this is all about increasing, decreasing, right? Because if the derivative is positive, it's increasing. If it's negative, it's decreasing. So this is all about increasing and decreasing. Then we get that, the limit as x approaches -1 from the left is -1, and from the right, it's negative infinity, and now it's positive infinity. So that explains why there was this jump at -1, because we've got a vertical asymptote. This tells me I've got a vertical asymptote at x equals -1. Here, I see that x goes to negative infinity, the output goes to 0. So this is telling me I've got a horizontal asymptote of y equals 0. But then on the other hand, here, there's a typo. That should be infinity, sorry. As x approaches infinity, f of x also approaches infinity. So there is no horizontal asymptote on the right-hand side. And then the last little bit here, the second derivative is negative whenever x is less than -1, and positive whenever x is bigger than -1. So this is about concavity. So this, what do I have? 11 pieces of information, and that is enough for me to really get a detailed graph. So I'm going to go ahead and just try to plot a graph. So I've got y-axis, x-axis, and what do I know? Some key spots. At 0, the function is 3, so I'm going to put that in. So maybe 1, 2, 3 is right about here. So I'm going through there. And then at 2, the value is 1. So 1, 2, maybe right here. So that's a key spot. I know that the derivative is 0 here. So I know that the graph will kind of flatten out. So I'm just going to kind of put a little line right here. Let me know that my graph's going to flatten out right there because I'm going to have a slope of 0. It's going to have a horizontal slope. So the derivative is negative whenever x is less than -1. So let's take a look. Let's say this is -1. And we know that because the derivative is negative, it's going to be decreasing. And then it says, oh, wait, we're going to keep decreasing all the way up to, so this spot is where 2 is. So it'll decrease all the way up to here. So it's also decreasing here. And then after that, after 2, we're told that the derivative is positive. So from here on out, it'll be increasing. So what else do we know? As the limit as x approaches -1, so we know we've got a vertical asymptote here. So let's go ahead and just put that. So I've got a vertical asymptote at -1. And it goes to negative infinity from the left. So I know it's going down this way to the left, and it's going to positive infinity from the right. So it has to be going up like that. I know I have a horizontal asymptote as x goes to negative infinity. So it's going to have to approach 0, coming that direction. But it's going to grow without bound from the other direction. And then the last little bit I could put in here is about concavity. So I know that from uh, x less than -1, it's concave down. So all the way throughout here, it's going to be concave down. But then after that, as we go to the left, it's going to be concave up. So everywhere from here on, it'll be concave up. And now let's just put all this information together. So I know that as x goes to negative infinity, it's going to 0. Can it cross this x-axis? Well, if it did, then I would have to, so say it's coming this way and it crosses the axis and then comes back down. Well, it would have been increasing, then decreasing. But I know it's decreasing the whole time. Also, it changed concavity. So the only way you could do it is got to be shaped like this. So it's got to be concave down, always decreasing. Then from here to here, well, it's going to be concave up, this whole region. It's going to decrease, decrease, decrease till I hit to 2, and then increase. So the only way that can happen is it's going to have to look something like this. And then after that, it'll be concave up and increasing and going to infinity. So its shape has to be something like this. So here's the general shape. This meets all of the definitions, and I see I've got a local min here. So I go to the left, it's as x goes to negative infinity, f of x goes to 0, sure enough. As x approaches -1 from the left, it's going to negative infinity. As I approach from the right, it's going to positive infinity. As x goes to infinity, the function's going to infinity. The second derivative has to be positive in this whole region from -1 to infinity, sure enough. And then it has to be, second derivative have to be negative because I'm concave down. And then it's decreasing, decreasing, so the first derivative is negative, and then finally increasing. I meet all of the requirements, and this is exactly what the graph has to look like.